I will not be recording the tutorial, obviously. So I mean, there's no point to record a tutorial. Within this tutorial chat where you are now, I will attach the tutorial file. You all can attempt it. If there's a lot of students, I will group you all up. But if there's just a few students, then I will. Okay, if there's just a few students, then you all can try everything lah. Okay, let me just find the file on my computer. Tutorial 4, yes. Okay, so I'm attaching the tutorial 4 inside the meeting chat. All of you should be able to download the PDF file. You can take a look at it. I will open it up on my computer as well. Yeah, so there are 6 questions. Minimum, you should try question 1. Question 2 to 4 are basically the same question. Question 5 and question 6. So these are the 4 different groups of questions. Okay. If you have any queries, just turn on your mic and ask. Okay. Otherwise, generally you will want to leave your mic off. Because like as you can see now that I think it's Junjae, when he turns on his mic, then you can actually hear echo of my voice. So we try to have everyone mute, but when you have a question, just unmute and ask. No problem. Okay. Is my voice clear? Okay. So you have the tutorial. I will be monitoring the chat and I will have my headphones on if anybody has a question. Later on, you should be able to see my screen now. Later on, I will be. Let's see. Can you all see what I'm writing? Okay, so later on we will be using this for me to work through the questions. For now, there will be nothing here. I'll just leave this leave this up. Y'all can go and attempt up to about 9:20, 9:30 or so. Then we will run through the questions. Yep. So I will mute as well. Any questions? You can either message, I will see, or you can unmute your mic and ask the question. I will answer. Okay. Hi Junje, are you able to download it? Okay. Nicholas, Chiwei, Yongsheng, are you able to download? Okay. So Junje, you're on a phone or on a computer? Computer. Okay. This is a bug with. Okay. Can you send me a WhatsApp? I will WhatsApp you the file. Still waiting for your WhatsApp message, Junje. Okay, I think we have some new people. Yeah, welcome. I don't see Shaban, worryingly. Anyway, if you check the chat history here, scroll up, I have uploaded the tutorial 4. You can download the tutorial. Shaban, you're here, right? Okay, so I've uploaded a tutorial. You just scroll up in the chat. You can download the tutorial, make attempt. As I was telling those who were here earlier, question 1, you should try that. Questions 2 to 4 is the same question. If you can do one, the rest are about the same. Question 5 and question 6. So you can attempt that. About 9:30, I will be going through going through the tutorial. But I want you all to attempt first. Okay, any questions? Do chat here, or you can just on your mic and just talk. But don't leave your mic on, because obviously then you have echo and things like that. Shaban, are you here?
Hello?
Okay, yes, everyone is here. So you just scroll up, you can download the tutorial. Please mute your mic, by the way. Okay, so you scroll up, you can download the tutorial. I posted it up at 9 a.m. so you can look for the timestamp. Download that, you can try it out. You should be able to see my screen where, yeah, there's just something called Inkscape. Later on, I'll be working out the tutorial for y'all. But for now, I want y'all to attempt first. About 9:30 or so, we will run through some of the questions. So you do question 1. Questions 2 to 4 are the same thing, so just try one of them. Then do question 5 and question 6. Try them out. Mostly common sense. Yeah, if it's like, okay, so you have 120 meters and the split is 4 meters. So use your common sense. This is not something that needs so much the formula. It's just thinking through. It will be covered more detail in the lecture. Okay, welcome Guan Hong. Please scroll up to the top of the chat. You can see the tutorial sheet. You can download, try the questions. 1, 2, 5, and 6. And about 9:30, I'll be running through the tutorial. But I want you all to attempt first. If you are not sure something, ask in the chat, or you can on your mic and ask here. Yes, next week, same time, we will also cover this tutorial, Ying Hao. You're welcome. Okay, so hopefully you all have managed to try. Let me get my drawing tablet up and running. Let's test this. Okay, should be fine. Everybody who's there, give me a yes in the chat. Okay, so first of all, let's go for, oh yeah. Okay, let's go for question 1. How many parts on this conveyor system? You can type the answer, or it might be easier to just unmute and tell me the answer. Everybody can hear as well. Shaban, that's you. How many?
30.
30 parts. Okay, that's correct. Everybody should have gotten the same thing. Thank you, Shaban. So because there's a 120-meter delivery loop, and every 4 meters there is a conveyor, so you just divide that. The return loop is 80 meters, but of course, once it's on the return loop, there's no part on it. It's just a hook, right? So thank you, Shaban. Now for the second one, what is the part flow rate? Meaning how many parts per unit of time? Okay, anybody can tell me that? Okay, thanks, Chewe. So 0.3125. Are you sure it's per minute? Check your units, please. Because you are using your conveyor speed, which is 1.25 meters per second. Yeah, so correct. So if 0.3125 parts per second, which is just basically 1.25 times 1, because each carrier got 1 part, and divide by the every 4 meters there's a carrier. So you get 0.3125. How many is that if you are converting to hour? So 0.3125 is every second there will be 0.3125 parts. So if we want to convert to hour, we have to multiply by 60 to be minutes and multiply by 60 again to be hours. So you get 1125 parts per hour. Okay, so this is not like strictly required, but generally speaking, when we are looking at the flow rate, we count per hour because 0.3125 is a very awkward number. So 1125 parts per hour. Okay, so last question. What is the maximum loading and unloading times which are compatible with the operation of this conveyor system? Anyone? Okay, so your number of parts was 30 and your flow rate is 1125. Why is this lagging? Okay, I'm not sure why my thing is lagging. Give me a minute to check. No, it's fine. Okay, so in order for it to be able to load, basically you must be able to load as fast as you produce or as fast as your parts are flowing. Okay, so if your parts are flowing 0.3125 parts per second, that means you within how to say that your part can only take 1 over 0.3125 times to load or unload. Because if it takes longer than that, then you cannot produce at the rate of 0.3125. Okay, shorter is fine. Okay, so when you do 1 over 3.3125, what you get is 3.2 seconds. So if your loading or unloading takes 3 seconds, that's fine. You can still sustain the part flow. But if it takes anything more than 3.2 seconds, then it is not suitable already. Okay, so the answer there is your T should be less than 3.2 seconds. Okay, so normally we put TL for loading, TU for unloading, also less than 3.2 seconds. Stupid dot. Okay, so that's our question 1. So now, question 2. If you tried question 2, say yes in the chat. Nobody tried, huh? Anybody tried question 3 or 4? Please say yes in the chat. Type here if you are still present and not sleeping. Okay. Okay, so this is how we are doing it. Okay, so questions 2, 3, and 4 are basically the same question. Okay, so I'll describe the question first. We have our conveyor. Closed loop means that the conveyor is basically one round. It goes round and round and round, closed. So there's no start or stop of it. Okay, so we need to reach 300 parts per hour. That's sentence 2. We are trying to determine how much space between our carriers. Okay, so you have some type of carriers, a basket, a hook, whatever. So every carrier holds one part. That's the 4th sentence. Your forward and return loops will be 90 meters long, and your conveyor speed is 0.5 meters per second. So these are all fixed things. Okay, loading and unloading takes 12 seconds. So all we are trying to do is it feasible? And if it is feasible, how many carriers and spacing between carriers? Now, first thing you will note is that okay, so your total distance is 180 meters. Therefore, your conveyor speed of 0.5 meters per second, your number of carriers and spacing between carriers are interlinked. Okay, so if you have 2 carriers, the spacing will be 90. If you have 3 carriers, the spacing will be 60. Okay, because it's just inverse of each other. So you need to calculate one or the other. Now, let's look at our flow rate, part flow rate. What happens with part flow rate is we want 300. Okay, so we put 300 here. How do we calculate part flow rate? Okay, part flow rate depends on. Okay, give me a minute. I have a phone call. I hope it's not university. Okay, sorry about that. We are from Price Solutions trying to offer me a loan. I think a lot of people are hard up for money now. Anyway, not important. So where were we? Okay, so we have 300 parts per hour flow rate, which is basically it is 0.5 meters per second over whatever our spacing is. So you have seen this in your question 1 already. So let's call our spacing S. Okay, and we put part per hour. Okay, the other thing that we put in here is times 1, because every carrier has one part. This is important because when we do question 3 and question 4, this number here, this number will change. Okay, so 300 parts per hour equals to 0.5 meter per second times 1 over S. Therefore, we can calculate our spacing here. Now, take note that this is hour, this is second. So you need to convert. Okay, once you do all the conversion, you will find that spacing is, I think, 6 meters. Okay, you all can try the maths. It's not very hard. This is all in the solutions as well. It's a bit more formally put in the solution. Okay, so spacing in order to hit 300 parts per hour is 6 meters. Okay, this is the appropriate spacing. If you have this spacing, how many carriers do you have? So if you look up here, we have 6 meters, 6 meters, 6 meters. How many carriers? It is just number of carriers is equals to 180 meters divided by 6 meters, which is equals to 30. Okay, so 6 meters, 30 carriers. These two numbers are directly related, 6 meters and 30 carriers. At this point, I need to ask, some of you, I know you're watching on phone, some are watching on computer. Are you able to see what I am writing? Is it too small? Okay, so if you cannot see any issue, you must let me know, because not like in class where I can see people are looking blur. Right now, I can't see your face, and I don't want to see your face. I can't see everybody's face together anyway. Oh, Shaban on phone, good. Is it like some huge Mi Max or something? Never mind. So what we have here is a spacing, 6 meters, number of carriers 30. But there's one part of the question we haven't answered, which is the system feasible? So when we talk about feasible, how do we calculate that things are feasible? Okay, in order to calculate that things are feasible, we want to look at whether the rate can be sustained. Okay, the rate can be sustained. We have already calculated that at 0.5 meters per second and 6 meters spacing, which is 30 carriers, we can produce. Okay, this 6 meters seems like quite okay. If your answer here is your spacing needs to be 0.1 millimeters, then there is a limit how small this can be. But 6 meters, definitely you have quite a good room. But the other thing here is the other number you are provided is 12 seconds. Okay, TL equals to TU equals to 12 seconds. Always remember, use the units for this kind of question because it really helps. So loading time, unloading time is 12 seconds. Is this enough? Okay, and if we want to know whether it's enough, then let's see, where is my formula here? So what is the formula for loading time? As we have seen before, your loading time should be less than or equals to your spacing over your velocity. Our spacing here is 6 over 0.5 meters per second. Okay, which means that your T should be less than or equals to 12. Fortunately, our loading and unloading time is 12 seconds and is less than or equal to 12. So we can say for A, feasible. Okay, so this is question 2, feasible. Now, let me just change the color. Let's look at question 3. Okay, so you can scroll down in whatever you're doing here. Question 3 is the same question, but there are 2 more things which are specified. First, for question 3, why is my... Okay, good. So for question 3, this number here becomes 2. Okay, why? Because now there are 2 parts in one carrier. So previously was 1, now it's 2. How does that change? S is now 12 meters. If F is 12 meters, number of carriers is 15. Okay, so the red is the numbers which has changed. This has changed to 2. This has changed to 12. This has changed to 15. Okay, 12 meters, 15 sounds even more doable, which makes sense because now you can carry more parts. You need less carriers. Okay, let's look at the timing. The equation for the timing is now different. Okay, the question says TL equals to 9 plus 3 NP. NP here is the number of parts. So in this case, number of parts is 2. So 9 plus 6 is 15 seconds. Okay, so what now we need is that can this 15 seconds be less than S over V? Okay, and let's look at that. So our S over V less than equals to, our S now is, where's my S? 12 over 0.5 equals to 24. So 15 is definitely less than 24. So for the second one, feasible. Okay, so this is question 3. So by now you should be getting the idea. Let's go to, let's go to question 4. For question 4, okay, for question 4, this becomes 4. Right, so everything is the same, but instead of 1 part or 2 parts, now we have 4 parts. And when this becomes 4, this becomes a spacing of 24 meters. And this becomes 7.5. Okay, if we quickly go to our maths here, our equation is still 9 plus 3p. So 9 plus 3 times 4 equals to 21 seconds. T is less than or equals to 24 over 0.5 equals to 48. So from the timing here, it is feasible. Okay, the only problem with this blue color, which is for question 4, is this number here. What is this? This is saying that your number of carriers is 7.5. Okay, 7.5 is not a round number, which means that having 24 meter spacing, you must have 7.5 carriers here. How do you get 0.5 of a carrier? Okay, so it means that as stated, this is not feasible. Because what this is saying is if we want exactly 300 parts per hour, we need 7.5 carriers. 7.5 doesn't make sense. Okay, obviously we can make it 8 carriers. What happens when we make this 8 carriers? When we make it 8 carriers, this number goes up. Okay, and it becomes like 325 or something like that. So we are not fulfilling the specification of 300 parts per hour. Okay, so it is not feasible, but it's not feasible in the sense that it cannot sustain. It's not feasible in the sense that we cannot hit the target exactly. Okay, so that's the only difference for question 4. Okay, any questions for questions 2, 3, 4? Okay, now let's go to question 5. Question 5, you have an AGV where we look at all these average travel distances, blah, 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 blah. So you take 220 meters, you deliver. And then your empty travel distance is 160 meters. Your load and unload times are 24 seconds. You have a speed 1 meter per second. Then you have something called traffic factor and availability. Now, just a very simple question. Traffic factor will make your production speed faster or slower? What do you think? Faster or slower? Just type in the chat. definitely slower, right? Okay, traffic factor is traffic. So if, when you drive to uni, of course, if today you drive, the traffic factor very low. That means no traffic basically. Okay, if you got no traffic, then of course you will have faster travel. If you got a lot of traffic, you got slower travel. Okay, availability is similar thing. If your availability, maybe some of you take the bus. If your bus comes every second, very high availability, then your travel time is less. Okay, your speed is more. But if the bus comes every 35 minutes, then your travel time is longer. Okay, so both this traffic factor and availability, there are numbers which reduce your rate. Okay, so that's the logic here. Okay, let me figure out how to change back my color. Yeah, okay. So basically what we are trying to do is say how long does the average delivery take. Okay, so the average delivery looks something like this. First you have to load. Okay, then you have to travel while loaded. And then you have to unload. And then you have to travel while empty. Okay, so these four things will give you your total travel time. Okay, so we had the numbers for this, which is just 24 to load. Your loaded travel is 220 meters divided by 1 meter per second. So that's it. So you must make sure it's in second, okay? So meter per second. Make sure you have your units correct. Unload is 24 seconds. Empty travel is 160 meter per second over 1 meter per second. Okay, if I want to be tricky here, I can say, oh, empty, it travels at 2 meter per second. But you just change the number here, right? This is not hard. Okay, so how much is the total time here? 244, 268, 300, 428. So what we have is 428 seconds, which I think is about 7.13 minutes. Okay, I may get some of the maths wrong. I don't think so, but if I get the maths wrong, just raise it up in the chat. Okay, so this, what is this? This is the average travel time. Okay, and if you have a certain average travel time, then we can use that travel time to calculate how fast or what's our speed of delivery. Okay, and our speed of delivery is just our rate. Okay, so we can say it's our rate is equals to 1 over travel time. Okay, so when we have 1 over travel time, then this is our how many deliveries per minute. Okay, so once you have these deliveries per minute, then you need to convert it to hours. Okay, which means you need to times 60 to get it to hours. Then you need to multiply by the two factors that we have as well. Okay, so your deliveries per minute, you have R times 60 times 0.9 times 0.94. Okay, at the end here, you will get 7.12 deliveries per hour. Okay, why we need to convert to hours? Because the question asked for 35. So if we wanted 35 deliveries per hour, then how many AGVs do we need? Each AGV gives 7. So what you have is N equals to 35 over 7.12, which is equals to 4.92. So you need more than 4.92. Less than 4.92 cannot. 4.92 and above can. So we can just say we need 5 vehicles. Okay, once again, the maths here is not hard. It's just about taking the numbers you're given, looking at the units, thinking logically. Okay, this is not a very like maths for engineering type of complicated subject. Okay, That's question 5. Any questions so far? Okay, then let's look at question 6. In question 6, you both have a question and a diagram, okay, which whether helpful or not. Then there's a few concepts that we bring out in question 6. I will talk about this more in lecture lah. Basically, here you have a rail guided vehicle system, which basically is like a train on a track. Okay, that's what rail guided means. And you're trying to move parts between stations. Sentence number 3 is important. So you have your 1, 2, 3, 4. All work parts are loaded at 1. Then they go to either 2 or 3 or 4, and then they come back to 1. Okay. Sentence 4 says, once it's loaded, the work part stays on the vehicle throughout its time. So basically, this vehicle is not drop it off and then go back. The vehicle carries the part the whole time. Then we give the load and unload time, processing time, production, how frequently production, all these type of things. Okay, so this question has quite a few parts. Part A is let's have a from to chart. Okay, what is a from to chart? A from to chart is basically to try and show, from this to this, how far, which is the distance, and how many trips. Okay, so if you look at the diagram there, we can calculate how far. I'm not going to draw the diagram again, but it basically looks like this, like this, like this. Okay, so here's 1, 2, 3, 4. Now, to travel from 1 to 2, you travel this distance, which in the graph says 10 meters. This distance is 10 meters. This distance is 10 meters. So from 1 to 2 is 30 meters. Coming back is 5 plus 10 plus 5, which is 20 meters. Okay. The distance from 1 to 3 is 10 plus 10 plus 10 plus 10, 40 meters. Coming back is 5 plus 10 plus 10 plus 10, 30 meters. And similarly, going here is 50 meters. 10, 10, 10, 10, 10. So 50. And coming back is 5, 10, 10, 10, 5. So it's 40 meters. Okay. So in our chart, we are going for something like this. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So this is the from, this is the to. So from 1 to 1, there's no travel. Okay, nothing is going from station 1 to station 1. From station 1 to station 2, how many parts? There are 7 parts, and we already calculated is 30 meters. Okay, there are 7 parts per, let's see, per what? What does my question say? There are 7 parts per hour. Yeah, 7 parts per hour go to from station 1 to station 2, and the distance is 30 meters. For station 1 until station 3, we have 6 parts per hour, and it's further, it's 40. Station 1 to station 4, we have 5 parts per hour, 50. So this number, because the question asks how many and how far. So this is the how many, this is the how far. Okay, this is coming out from station 1. What about from station 2? From station 2 going to station 1, there are 7 parts. Why? Because station 1 to station 2 got 7 parts per hour. Station 2 coming back to station 1 also 7 parts per hour. Okay, so here is 7, but the distance here is 20. 5, 10, 5. Okay, from station 2 to station 2, nothing. And from station 2 to station 3, nothing also. Okay, I'm not going to write 0, 0 lah. I'm just going to. Okay, all these are blank because station 2, 3, 4, they do not travel to each other. So we are only filling in here and here. This one is 6:30 because from station 3 going to station 1, coming back here is 6 parts per hour and the distance is 30. From station 4 going to station 1, it is 5, 40. Okay, so this is our from to chart. This chart is basically so that we can realize who goes where, how often, which is the 7, 6, 5, 7, 6, 5, and how far, 20, 30, 40, 30, 40, 50. Okay, so this is part A. Part B asks for a network diagram. This one is quite simple. Basically, you take this information, which is in a table, and you say, hey, how are they related to each other, each of these stations? So if we have station 1 here, and we have station 2 here, going from station 1 to station 2, we have 7 units per hour, 30 meters. Going back, we have 7 units per hour, travel of 20 meters. What about to station 3? Okay, let's put station 3 here. Going there, we have 6, 40. Coming back, we have 6, 30. And obviously, for station 4, going there, we have 5, 50. Coming back, we have 5, 40. Okay, yeah, it fits exactly. So this is what we call a network diagram, which shows the travel. Now, this is very, very simple, this network diagram. If, for example, you have a sort of system where it goes from 1 to 2, 2 to 3, and then 3 to 1. Also goes 1 to 2, 2 to 4, 4 to 3, 3 to 1. Okay, then you can see that here there might be some flow from 2 to 4, 3 to 4. So the network diagram, this is like the simplest already. Just 1 to 2, 2 to 1. 1 to 4, 4 to 1. 1 to 3, 3 to 1. Okay, so but it can get more complicated depending what the question is. So once we have all these diagram and table, then it is time to do your calculation. Again, this is not something that needs a formula or what. So unlike your previous tutorial where I will give a formula, this one isn't something really to do with formula. So the question says, determine the number of guided vehicles to meet the requirements of this flexible manufacturing system. So we are given the speed, we are given the traffic factor, and we assume reliability is 100%. Okay, so this is actually quite same as question 5, but question 5 gives us the information directly. Here we have to calculate the information ourselves. So please look back at question 5 and see what's the information that they give you. They give you the average travel distance for each delivery and the average empty travel distance. So can we calculate that for question 6? If we want to calculate the average travel distance for the vehicle, how do we do that? Okay, and here we can either use our result for A, the from to chart, or we can use the network. Both of them give the same thing. Basically, how far will our AGV travel? So if the AGV travels in your, okay, where am I? If the AGV travels to 3, it travels 40 plus 30, which is 70 meters. If it travels to 2, it's 30 plus 20, 50 meters. If it travels to 4, it's 50 plus 40, 90 meters. So 90 meters here, 70 meters here, 50 meters here. What's the average of that? You don't add 90 plus 70 plus 50 divided by 3. Because the number of times it travels depends on how many production per hour. Here has 7, here has 6, here has 5. So if we want to find the average, we do it this way. It's a weighted average. Okay, so the distance traveled is equals to 7 times 50. So because 50 meters to station 2 and they are 7 times per hour, plus 6 times 70 plus 5 times 90. Then because it's weighted, we must divide by 7 plus 6 plus 5. Okay, so this is just total distance traveled each way, and we weight it by how many times we have to do it. Okay, all makes sense. The answer 67.7 meters. Okay, now if 67.7 meters is the distance traveled, that will allow us to calculate the time taken. Okay, because we have, let me check the speed that we're given. we are given a speed of, where's our speed? Oh, 60 meters per minute. Okay, speed is 60 meters per minute. Okay, so we have our distance, we have our travel speed. The other thing that takes time is what is the load and unload times. Okay, so TL equals to TU equals to 1 minute. Okay, and our factor, traffic factor equals to 0.85. Once we have all these numbers, then this one looks exactly like question 5 already. Okay, and we can do the calculations that way. So what is the total time taken? Time taken equals to, oh wait, we can't use this 1 minute because this 1 minute is for a single load. Okay, in order to calculate, we need the weighted average of how many loads as well, which is no, not correct. Well, 1 minute is for a single load, but there's also our processing time. Okay, how do we calculate the processing time? If you look at the question, it is 5 minutes for station 2, 7 minutes for station 3, 9 minutes for station 4. So similar to what we were doing here, where we weight out the distance, we can also find the average processing time. So average processing time is 1 minute to load plus 7 times 5 plus 6 times 7 plus 5 times 9 over 7 plus 6 plus 5. Okay, plus 1. So loading time, processing time, unloading time. This is not calculating travel time yet. So on average, how long would this take? This would take 8.78 minutes. Okay, so average time spent for loading, unloading, and processing is 8.78. If we want to see total average time, T is equals to 8.78 minutes plus our average distance over our average speed. Okay, and this will give us a time of, okay, how many minutes it will take. Okay, so 8.78 plus 67. Okay, I realize there is a typo in my solutions. Let me just quickly open my calculator here. 8.78 plus 67.7 over 60. Okay, so this one will be equals to 9.91 minutes. Okay, so 9.91 minutes. If we have 9.91 minutes, this is the average amount of time which will be taken. Okay, for what is this here? Average amount of be taken for one cycle, for the vehicle itself to finish one cycle, loading, travel, unloading, travel back. So one cycle takes 9.91 minutes. Since we know this, then we can say that our rate, our flow rate, is equals to 1 over 9.91. Okay, but of course this is in minutes, so we want to times 60 because flow rate we generally do in hours, and then we have to apply the factor, traffic factor. Traffic factor is like, oh, sometimes it wants to travel, it's blocked by another one. Okay, so this is traffic factor. We do all of this, we will get our flow rate of 5.15 per hour. Okay, once we have 5.15 per hour, then the question is, how many vehicles do we need? Okay, And if you want to count how many vehicles do we need, we have to count, oh, how many times do they have to travel per hour? So in order to see how many times they travel per hour, we can go back up to our network graph here. And what do we see here? We see that every hour there must be 7 trips in this direction to 2, 5 trips in this direction to 4, 6 trips in this direction to 3. So total trips 7 plus 6 plus 5 is 18. Okay, so now we go back here, 5.15. So the number that we need is 18 over 5.15, which is about equals to 3.5. So we need more than that. Therefore, the answer is 4 vehicles. Okay, so this is for question 6. That concludes our tutorial. Any questions for those of you here? Okay, any further questions? Last chance. Otherwise, we will dismiss the class. Solutions will be uploaded after next Wednesday morning's class. So just like the previous one, once I finish all 4 sessions of tutorial, then I will upload the solutions. Okay. Otherwise, I will see you later, 3 to 4 p.m. Thank you for attending. Please leave the meeting now. Then I will close it once every